Welcome to Concentration Units 2. In this video, we're going to take a look at some calculations involving molality, percent, and mole fraction. So we're going to start with molality. And here's the question. A solution is made by mixing 10.0 milliliters of isopropyl alcohol with 100.0 milliliters of ethanol. What is the molality of this solution? So molality is one of our new units. So we'll take this time to remind you that molality is moles of the solute per kilogram of the solvent. So again, the denominator is different from molarity. It's not the liters of the whole solution. It's kilograms of just the solvent. So take a look at our story here that accompanies this problem and decide what is the solute and what is the solvent. And then pause the video and take a moment to try and calculate the molality. All right, so again, molality is moles of our solute. That is the material that's there in the smaller amount per kilogram of our solvent. That is our material that is there in the larger amount. So our solute is the isopropyl alcohol, which is abbreviated IA in the little box on the right. And our solvent then is ethanol there at 100 milliliters. And it is going to be abbreviated ET in the box on the right. Okay, so to begin with, we need to come up with the moles of our solute. That's our isopropyl alcohol. So starting with our 10 milliliters of isopropyl alcohol, we can use the density that is provided in order to convert that milliliters, that volume of our solute, into grams. And then once we have grams of our isopropyl alcohol, we can use the molar mass then to find moles of isopropyl alcohol. So that conversion is displayed on the screen for you. We're going to do something similar to come up with the kilograms of our solvent. We need to get from our 100 milliliters of our solvent ethanol into kilograms. So here we're also going to need to use the density to convert from the volume that we're given, the 100.0 milliliters of ethanol. We'll use our density to convert into grams of ethanol. And here we don't need to find moles. We do need to change that unit from grams to kilograms. So we need to use our prefix conversions. And then we can calculate the kilograms of the ethanol. Now all that remains is to put those two pieces together. So the moles of the solute, our isopropyl alcohol, will be on the top, and our kilograms of our solvent, our ethanol, will be on the bottom. And we can carry out that calculation, and we get 1.66 moles of isopropyl alcohol per kilogram of ethanol. Those units don't cancel out, but like molarity, we have a little symbol we can use for molality. And it is a curvy little lowercase m. So it's not just a plain m, that would be for meters. It's got a little curve or a little bit of italics to it. So maybe make it a little bit more like a cursive m for those who are writing it out. So you can tell the difference between the molality and meters and molarity, which is just a large capital M. Now we'll move on to percent. So our second question is, effective hand sanitizer should be at least 60% alcohol by volume. And brand X contains 18 milliliters of alcohol in every fluid ounce of hand sanitizer. And you want to know, is brand X effective? Should I bother to purchase it, or is it not going to do the job I need it to do? All right, so you're going to need to have some information about what a fluid ounce is. So it is 1 fluid ounce is equal to 29.57 milliliters. So now we need to think about what the definition of percent by volume is. Okay, so that percent, like any other percent, is going to be the part over the whole times 100%. And the part in this case is the part that is due to the alcohol versus the whole. What is the volume of our whole solution, of our whole hand sanitizer in this case? So we need to have those two volumes in the same unit. So we can either change our milliliters into fluid ounces, or we can change our fluid ounces into milliliters. Either one will give us the same result. In this case, I changed my 1 fluid ounce into milliliters. So in the top of that proportion is the volume of alcohol. That's our 18 milliliters. In the denominator is the volume of our hand sanitizer. So that is the 1 fluid ounce. And then there's a conversion between fluid ounces and milliliters. 1 fluid ounce, 29.57 milliliters. And then times 100% to get us on that percent scale. And we find that our percent volume for this hand sanitizer is 61%. So yes, brand X is effective. All right, we will conclude this video with our last question dealing with mole fraction. So we have 52.8 grams of glucose, and there's glucose's formula, C6H12O6. So that grams is dissolved in 158.0 grams of water. What is the mole fraction of water in this solution? So that mole fraction, again, is almost exactly what you would expect of it. It is the moles of water. That's the part, right? Since this is a fraction. The part that we're interested in, the moles of water, so we symbolize that with N for moles, divided by the total number of moles. So the moles of glucose plus the moles of water. And it is given the symbol that looks like a capital X. It's called the mole fraction. It's chi. It's a Greek letter. It looks like an X though. So again, and I'm going to use subscripts to tell us what each of those mole fractions and moles is referring to. So the mole fraction of water is equal to the moles of water over the moles of glucose plus the moles of water. So we're going to have to do some calculating to figure out the moles of each of our components, and then recombine them to form our overall mole fraction for water. All right, so I hope we remember how to do this, how to get from grams, which is the information we have on all of our materials, solute and solvent. To get from grams into moles, we need to know the molar mass of each of those components. So given the formula of glucose, and I hope we all know what the formula of water is by now, it's H2O. We can make those conversions from grams into moles of each of those components. So when we do that for glucose, we get 0.293 moles of glucose. And when we do the same calculation for water, starting with its mass and its molar mass of 18.02 grams of water per mole, we get 8.77 moles of water. And now we need to put that all together again into our mole fraction relationship. And that is that the mole fraction of our water is the moles of water, 8.77 moles of water, divided by the total moles. That's our moles of glucose, 0.293 moles, plus the moles of our water, 8.77 moles, and our mole fraction is 0.968. So that is the mole fraction of water. As a side note, all the mole fractions have to add up to 1. So we already know the mole fraction of our glucose then is 1 minus the mole fraction of water, or 0.032. Well, thank you for joining me for Concentration Units 2. I hope to see you in our last video in this series, where we learn about converting these different units of concentration. See you soon.